Okay, so this is a pre-lesson to solving equations. This is just a basic one-step equation review. This is really not an 8th grade math skill, but it builds up to some 8th grade skills, and we're going to go ahead and go over this just to make sure that we all understand how to solve a basic equation. I'm going to start here with looking at the parts of an equation. This is just a basic equation that would take one step to solve. 5 at the front of this equation is called a coefficient because it is a number that is being multiplied by the variable. When it's right beside the variable, that means they're being multiplied. X is the variable. It's an unknown value, and you'll see it represented typically by a letter. And then 20 is a constant. It's a constant because it is a number by itself. It's constantly the same. 20 is always 20. When we go to solve these equations, we're going to use the inverse operation. That means we're going to do the opposite operation of what the equation included. So in our first problem, 5x equals 20, it involves multiplying 5 by x. And so we would actually divide both sides by 5 to undo multiplying. And so our goal is to isolate the variable. That means we want to get x by itself, and our answer will be x equal a number. So for this problem, 5x equal 20, we're going to divide both sides by 5 because it was already multiplied, and 5x divided by 5 is x, and 20 divided by 5 is 4. So we solved by using the inverse operation, and we isolated our variable. We got x equal 4 by itself. So we're going to practice solving just a few of these. We have y minus 17 equal 11. We're trying to get y by itself, so we need to undo this subtracting 17. So the inverse is adding 17. We'll do that to both sides of this equation. So we get y equal 28. For part B, we have negative 4.2p equals 12.6. So we have a number times p. So we're going to undo that by dividing both sides by this number, negative 4.2. And so on the left side, we get p. On the right side, a positive divided by a negative is a negative, and the result is negative 3. For equation C, we have a fraction 3/5 times w equals 3/16. We could go about this a couple of different ways. This is a fraction times w, so we could divide both sides by 3/5. I'm going to show you the way that would be simple to use if you were not using a calculator, which would be to just multiply by the inverse fraction. So if we take the fraction 3/5, and I'm just going to recopy the problem here, and we want to multiply by its inverse, we're going to multiply by its flipped fraction, which is 5/3. What we do to one side, we'll do to the other. And what happens is on this left side, the 3's will cross cancel. There's a 3 in the numerator and the denominator, so they'll cancel out to just 1's, and the 5's will cross cancel. There's a 5 in the numerator and the denominator, so they cancel out to 1's, and we just have one w left on the left side. On the right side, the 3's will cross out again, they'll cross cancel, but we still have 5/16 left, so we get w equals 5/16. Equation D, we have n minus negative 2/7 equals negative 3/7. So with n, we have minus a negative fraction. We could actually go ahead and just simplify this. That minus a negative is the same as a positive. So we have n plus 2/7 equals negative 3/7. And that's just going back to your integer rules. Minus a negative is the same thing as adding a positive. And now we want to get n by itself. So it was n plus 2/7. So we're going to undo adding 2/7 by subtracting 2/7. these have the same denominators, negative 3/7 minus 2/7, so we're going to get negative 5/7. So we have the equation t divided by 7.5 equal 4. So we have t divided by. So we're going to undo dividing by multiplying. So I'm going to go ahead and just rewrite my equation where I have some space. And I'm going to multiply both sides of the equation by 7.5. And you can use an X as a multiplication symbol. Sometimes that gets confusing with variables, so be careful about that. You could also use a parenthesis to show that you're multiplying. So let me just kind of show that as a reminder here. You could also use a dot for a multiplication symbol, but sometimes that gets confusing if decimals are involved. So I'm going to multiply both sides by 7.5. On this left side, 7.5 times t over 7.5 means that those will cross cancel. It's like saying 7.5 over 1. So if we were multiplying fractions, you could cross cancel the numerator of one to the denominator of the other. And we just have t on the left side. On the right side, 4 times 7.5 is 30. And we're finished.